Um, we're going to discuss domain and range, and quite frankly, this is going to be probably one of the first difficult concepts that we have in the year. And before I get into domain and range, I just want to make sure that we understand how to graph inequalities, because it becomes really important that we understand if it says, I guess I'll make it x equals less than or equal to -3, that we understand that we have a closed circle at 3. So we're saying it can be equal to 3 or it can be anything less than 3, right? Anything in this direction. Whereas if we have something like x is greater than 5, we know that it's not equal to 5, right? 5 is not greater than 5. So we're going to put an open circle, which means it's not part of the answer. However, anything more than 5 is. And we use open and closed circles. A closed circle means it's equal to, an open circle means it's not equal to. So if you think about it, if we look at something like x is greater than -7, I'm going to go here. I know that -7 isn't greater than -7, but I know that -6 is greater, and I'll put a closed circle. And I know that -5 is. I know that -4 is. And I know that -6.999 and -6.5 and -6.25, etc., etc. So what I want you to notice is as we start putting these infinity of closed circles, it begins to look a lot like something. And what that something is a line. And I think a lot of people don't really think about the fact that a line is nothing more than an infinity of closed circles. So humans have basically decided, hey, this is a pain, let's just do a line. And that means all these closed dots. And if you think about it, what does an infinity of open dots look like? It just looks like nothing, right? So this is an infinity of open dots to the left and an infinity of closed dots to the right. An infinity of open dots to the left, an infinity of closed dots to the right, an infinity of closed dots to the left, and an infinity of open dots to the right. So again, this equal to being a closed circle and not equal to being a open circle. The other thing is, this is the less than sign, right? And this is the greater than sign. So I'm saying x is less than 3 or x is greater than 5, and it could or could not be equal to. So I just want to kind of front load that because it's going to be really important with what we're going to do in this lesson. So hopefully you guys remember that from elementary school and junior high. So we'll go ahead and open this up again and get started on this. So again, we're looking at domain and range and how it relates to functions. So long story short, domain is going to be your inputs or your x values. Those are your x values or your inputs, or if you think about it, those are your independent variables. And range is the opposite of all this. Range is going to be your y value, your output, or your dependent variable. So your output or your range depends on your input or your domain. Now think about it. When I say x values, domain is going to be from left to right, range is going to be from up and down. And I know this might not make perfect sense right now, but again, I just think it's worth discussing before we jump into this. So examine the graph at the right, use it to estimate y when x equals -4. Well, when x equals -4, my output is right there. It looks like it's -1, 2, 3, like -3.7. Say it's about -3.7 is my y. What is your y when x equals 1? Well, when x equals 1, it can either be 2 or it can be -3. So we would say y equals 2 or y equals -3 when x equals 1. What about when x equals 4? Well, it could be 0, it could be 1, 2, 3, 4.2, and -1, -2, -2.2. So I'm getting y equals 1, 2, 3.2, about 3.2, or y equals 0, or y equals -1, 2.2, right? 3 potential answers there. Again, about -2.2. So is this a function? No, it's not a function because there's multiple outputs for some of these inputs, right? Some inputs have more than one output. So let's go ahead and look at 153. It says examine the function at the right. What is f of negative 3? So if I plug negative 3 in, I get 6 over negative 3 minus 3. I get 6 over negative 6. I get negative 1. So f of negative 3 equals negative 1. What about f of 0? Well, I get 6 over 0 minus 3. I get 6 over negative 3. So f of 0 appears to equal negative 2, right? That's going to equal negative 2. What about when I plug 2 into this equation? Well, I'm going to get 6 over 2 minus 3, which is 6 over negative 1, which will be negative 6. So f of 2 equals negative 6. Kind of got cut off right there, but it's a negative 6. All right, so this isn't really exciting, but it is going somewhere. What about when I plug in 3? Well, when I plug in 3, I get 3 minus 3, which is 6 over 0. And we've already talked about this several times. You're not allowed to divide by 0. So what happens? It breaks. There's no solution. I'm not allowed to plug in 3 to that. I'm not allowed to have 0 on the bottom. So it sort of breaks the equation. So are there any other inputs that cannot be evaluated by this function? In other words, are there any other values of x that cannot be? Well, we'll say no, right? Anything I plug in here except for 3 gives me a value. By the way, I'm going to jump over to Desmos real quickly just to show you what this looks like, because I think I want you to see what it means when the domain is restricted. So it was y equals 6 divided by x minus 3. So this was the equation, I believe. I just want to verify 6x minus 3. So if you look right here, you'll notice, it's kind of a cool graph, by the way. Again, you'll probably get to these when you get to integrated 3, but there's an output for every number, right? There's an output for negative 4, negative 3, negative 2, negative 1, 0, 1, 2, but there is no output at 3. You can see when I get to 3, it never quite, no matter how far back I go, it never quite gets to 3 on this one, and it never quite gets to 3 on this one. Now, it gets to negative 2.999. I'm sorry, it gets to 2.999, and it gets to 3.0001, but 3 is not allowed. 3 is restricted. It is not part of the domain. You're never allowed to put a 3 in here, but any other number would be fine. So that's what it means when we talk about the domain. Remember I said the domain is the x values? Okay, I'm not allowed to plug 3 into this equation. What number am I not allowed to get out of this equation, by the way? What is my range not going to be? Do you guys see my range will never be 0? I'll never quite get a 0 out of this equation. It'll get closer and closer to 0. If you're looking over here and saying, oh, look, it hits 0 there. Let me zoom in. You can see it doesn't hit 0. So my domain in this question is all numbers but 0. My range of this equation is all numbers. I'm sorry. My domain is all numbers but 3. My range is all numbers but 0. I know I'm kind of going off track here, a little bit more above and beyond what is being asked here, but I really want you to kind of see what's going on with that domain. So the set collection of numbers that can be used for x, the numbers that you're allowed to plug into an equation, is called the domain of a function. That is, the domain is a description or a list of all the possible x values of a function. Describe the domain of this. Well, the domain of this is all numbers but 0. You're not allowed to, I keep saying 0. You're not allowed to put 0 in the range. Domain is 3. So you can have all numbers but 3. You can plug any number in you want. And again, if it doesn't ask for range, but if it did, we would say the range is all numbers but 0. This is what I keep fixating on. I think I've said 0 instead of 3 multiple times already in this video. So what other types of functions have you looked at thus far in this course or in previous courses that have limited domains? Well, if you guys remember, we had one that looked like this, right? The square root of x. Well, we're not allowed to plug a negative in here because we said we don't know about the imaginary number I. So that has a limited domain. You can plug 0 in or 1 or 2 or 3 or anything positive, but you can't plug anything in less than 0. All right, so moving along, it says, now examine g of x graphed to right. So here's g of x. Is g of x a function? Yeah. each input has exactly one output, or it has no outputs, right? So I'd say yes, this is a function. Which x values have points on this graph? Well, anything between -2 and 4. Again, when I look at x values, I look from left to right. Right? I don't care how up and down it goes. I only care how left and right it goes. You'll notice -5, it's not on the graph. I'm not allowed to have -5 be here. 6, it's not on this graph. I'm not allowed to have a 6 here. So what are the possible inputs, or what is the domain of g of x? Well, it's between -2 and 4. And by the way, I know I already went over inequalities at the beginning of this video, and this is why. Here's what's easiest. Put the smallest number, then put x, and then put the biggest number. And then you're going to use the less than. -2 is smaller. Remember, x essentially stands for the graph, right? This is the domain. So I'm saying, oh, I can have numbers between -2 and +4. Can it be exactly -2? Well, it's a closed circle. Yeah, it can be exactly -2. Can it be exactly +4? Yeah, it's a closed circle. It can be exactly +4. So this is my domain. Now, what is my range? My range, now I'm grading it on the y-axis, not the x. I don't care about left and right anymore. I only care about up and down now. You can see the slowest this is ever going to be is right here at -1. The highest this is ever going to be is right here at 3. And again, this is a closed circle, and that's a closed circle. We already talked about that, right? All the connected dots. So anywhere here is a closed circle. So I can go between -1 and +3. So my range, it looks like not good there. So my range, the smallest it can be is -1. The largest it can be is 3. And I'm going to use the letter y for range. I use x for domain and y for range. And again, -1 is smaller than the picture, and the picture is smaller than 3. Can it be exactly -1? Yeah. I'll go ahead and put a underline, and it can be exactly 3. So I'll put that as well. So that's my domain, and that's my range of this. Again, what numbers can I plug in? I can plug any number I want in between -2 and 4. What number can I get out? I can get out any number from -1 to 3. For example, let's say I want to get a 5 out. I want to get a 5 out of here. Well, this is the wrong equation. I'm never going to get a 5 out of here. Let's say I really want to plug a 6 in. This is the wrong equation. I'm not allowed to plug a 6 in. So that's how this thing works. It basically limits what you can put in and what you can get out. And again, what you can put in from left to right, what you can get out up and down. So Ricky thinks the range is -1, 0, 1, 2, and 3. Not a bad idea, right? -1, 0, 1, 2, and 3. The only problem with that is, what about 2.5? And what about 1.5 and a quarter, right? So he's looking at it as if it was discrete and hopping, when really it's continuous. So yeah, we're going to say no, because it's through on that. All right, so let's try some of these. Let's go to 155 and let's try some of these. Is this right? I don't know if I'm on 123 or 131 or what anymore. Okay, so here we go. Determining domain and range. So first of all, we're going to answer, is this a function? And then we're going to say domain and range. First of all, is this a function? Of course, it's not a function. It's obviously not a function because here I have multiple outputs. So we'll say not a function. And what about my domain? Well, it gets as low as -3 and as high as +3. Again, domain is left and right. So it's going to be between -3 and 3. The question, and I'll put my less than sign. The question is, could it be exactly -3? It could. Could it be exactly +3? It could. Now what about my range? Well, that's up and down, and you can see again it's from -3 to 3, right? So, but this time I'll use a y. Make sure you use a y for range, again, because we're using the y-axis. And could it be exactly -3? Yeah. And could it be exactly +3? Yeah. So same thing. I can plug in between -3 and 3, and I can get out between -3 and 3. What about b? Is this a function? Yeah, it is a function. Each input has exactly one output, so we'll say it's a function. And we'll say the domain. These arrows means it goes forever from left to right, right? I can plug in a billion or -1 billion. I can plug in anything I want. So when it's anything you want, we're going to go with our good friend ARN. And ARN means all real numbers, but it's kind of a pain to write out all real numbers, so we'll just say ARN. That stands for all real numbers. And what about my range? I can get out anything up here. It goes forever up, right? It goes forever right, and it goes forever up. And this one goes forever left and forever down. So I can get any positive or negative, so all real numbers. Can't get any imaginary ones. All right, what about this one? Now you'll notice I have a closed circle here. I do not have a, I don't have an arrow, so it doesn't go forever in these directions, but it is a function. Each input has exactly one output. And when I do my domain here, the furthest left I can get is right here at -2. And the furthest right I can get here is right here at 4. And the question is, can I be exactly -2? And the answer is yes, there's a closed circle there. Can I be exactly +4? Yes, there's a closed circle there. What about the range? What's the most down I can go? -4. And what's the most up I can go? +2. Can I be exactly -4? Yeah, it's a closed circle. Can I be exactly +2? Yes, it's a closed circle. So you can see these are my domain and ranges. I hope this is making sense. I think we end up spending a second day on this because kids struggle so much, but feel free to ask any questions that you might have. Here, is this a function? Each input has exactly one output. So I would say, yes, it's a function. What's my domain? Well, it looks like it starts going straight up and down, but really, if I go to like -1 billion, it might be in China. I mean, it's going to be way, way, way down there, but there's nothing stopping me from going to the left. There's nothing stopping me from going to the right. So my domain is going to be all real numbers, but my range isn't going to be all real numbers. You can see right here, I can go as far down as I want, but when I go up, I stop at 4. Now, this is what's important here. Here you'll notice that there was 2 constraints and I had to use 2 inequalities. Here I had no constraints and I had no inequalities. Here I had 2 constraints and I had 2 inequalities. Well, here there's going to be 1 constraint at the top. There isn't one down, so I only need 1 equality. I'm going to say y is going to be less than or equal to 4, right? It can be anything below 4 or less. I only need 1 inequality to describe that. So that's really important to understand about that. As far as using those inequalities there. All right, if I go to E, is this thing a function? No. When I go here, I have multiple outputs, right? So I'll say it's not a function. What's the furthest left I can go? It looks like 2. What's the furthest right I can go? It looks like 4, and those are closed circles. So I will say 2 is less than or equal to x, which is less than or equal to 4. That's why I hope you see how important it is that we understand how to write these inequalities. And our range is the most up and down I can go. The furthest down I can go is -3, and it's a closed circle. The furthest up I can go is +2, and it's a closed circle. And finally, what about f? You can see, by the way, this is a log. You'll learn about this in Integrated 3. You'll see here, there is 1 input for each output. So this is a function. You can see domain, I can go as far as I want to the right, but to the left I stop at 0. There's no arrow here. There's no dot here either, but it is assumed to be a closed circle because you don't see the open circle. So again, if I only have 1 boundary, I only need 1 equation. So my domain, I'll say x is greater than or equal to 0, right? I'm more than or equal to 0. Whereas my range, again, I only have 1 boundary. It goes as high as it wants to go, slowly, but it goes up forever. But down, the lowest it'll go right there is at 3. So I'll say y is greater than or equal to 3. All right, let's go ahead and zoom back out and finish this thing up. Chewy loves tables. He decided to make a table below for a function to help him determine its domain and range. From his table, can you tell what the domain is for f of x, y, or y not? Well, it's a little bit difficult, right? I mean, it looks like it could be 0, 1, 2, 3, but I don't know. I mean, is it 0, 1, 1, 2, 2, 4, 3, 8, 4, 16, 5, 32? Or is it a curve? Like, is it everything in between, right? Does it go negative? I don't know. It's hard to tell by the table. So can you tell what the domain is? Not really. It's tough to, I'm kind of guessing, right? I don't know if it's discrete, meaning only the points, or if it's continuous, meaning I get to connect those points. It's hard to tell with the table. From the table, can you tell the range? And again, I don't know, is it 1, 2, 4, 8, 16, and 32? Or is it 1 through 32? I don't know. So again, it's hard to tell. I don't really know. The point is, tables aren't very effective, right? It's way easier to look at a graph to determine domain and range than it is a table, because we're left with questions about, what about 4.5? Is 4.5 okay? What about 20? Is 20 okay? I don't know. But when I look at a graph, I do know if it's okay. So a graph is better than a table for domain and range. Having said that, we can only go by what we actually are given. So if you got this on a test and it asked for the domain, what you would actually do is you would say 0, 1, 2, 3, 4, 5. And you would use commas. And for range, you would say 1, 2, 4, 8, 16, and 34. And again, we would always wonder in our hearts if there was other things that were allowed, but we could only answer what we have. So again, if you saw this on a test, this is how you would answer it. But really, hopefully, you understand that it's not super effective, that a graph is more effective. All right, Daniel was thinking about the function shown at right. He noticed the curve continues to the left and to the right. What is the domain of this function? Well, it goes forever to the left. It goes forever to the right. It looks like my domain is our good friend Arn. He found out that the dotted line is a line that the graph gets closer and closer to as y becomes very, very negative. Another name is asymptote. So it seems like if you went way over here, this dotted line would eventually get to this, this solid line, this curve would eventually get to this dotted line, but it wouldn't. It's an asymptote. It's like a wall. It never quite gets to the wall. You get closer and closer, but you never quite touch it. So how should he describe the range? Well, our range is at -2, right? So this is -2. What we're going to say is y is bigger than -2, and I think that's obvious, right? It's bigger than -2, but is it equal to -2? It's not. It will never be equal to -2. So this is going to be our range here. I'm not going to put that equal to sign because we don't know that it's equal to. So it says sketch the graph of a function that has a domain of all real numbers greater than or equal to -2. And a range of all real numbers less than or equal to 3. So what I could do, pretty simply, I go to -2, 3, and just draw a line that goes down, right? You can see my domain is all numbers greater than -2 or equal to -2, and my range is all numbers less than or equal to 3. So that would be one way you could do it. You could have done a lot of other ways, but that's just the one I chose. So an interesting lesson, like I said, definitely one of the first difficult lessons, I think, in the book this year. Historically, kids have a lot of questions with domain and range, so don't be afraid to ask.